Question 17, predict the product. Let's take a look at our starting compound right here. We see that this has 5 carbons on it, and our product has 7 carbons, meaning that we're adding 2 somewhere in the mixture. Where are those 2 coming from? Well, it should be pretty easy to tell that we're taking those 2 carbons from the second step of the reaction, and we're adding it on. But we got to figure out where this ethyl group gets added on, right? Does it go here? Does it go here? Does it go here? What's going to happen? Let's work through the reaction. Okay, we start with Na, sodium, NH2. This is an ionic compound. Anytime you see like sodium, potassium, you know that's going to be ionic. This has 2 lone pairs of electrons, making the NH2 negative. And then we can see that this is the NH2, it's actually going to act as a base, meaning that this is going to be our acid. So it's our job to determine which proton does it take, which H. There's some H's here on either end. There's also 2 H's in the middle. And using resonance structures, we're going to see that's actually going to be one of these H's in the middle. Why? Well, if we stole one of these H's, right, we'd be left with a lone pair of electrons that could do resonance between this double bond. But if we took one of these H's, there's resonance between both double bonds. And the more resonance, the more stable, that's the H that we're going to take. So, doing the reaction, we have our NaNH2. It's going to come steal this H. The electrons from that bond are going to be put in that center carbon right here, leaving us with a compound that looks like this. So 2 O's, and then our lone pair with a negative charge. Okay, first step done. What happens next? Well, this compound, this one right here, it gets reacted with our ethyl with oats, the OTS. Well, let's take a look at the reaction. We got our CH3, CH2. Actually, I'm going to write the CH2 all the way out so we could see exactly how it happened. So CH2 bonded to OTS. And this looks a lot like an SN2 reaction, right? We have our nucleophile right here. Nucleophiles have the negative charge. It's going to come in. It's going to attack this carbon, kicking OATS off. And we know that because OATS, OTS, is a good leaving group, which means that this ethyl right here, accidentally erased it, but that ethyl is actually going to be bonded to this central carbon. So let's get rid of all this clutter and see what our final product looks like. We're taking our starting compound and we're adding an ethyl to the middle, and that's it. Let's check the number of carbons and hydrogens just to be sure. We should always do that. We have CH3, so CH3, another CH3, CH3, another CH3, CH2, and then these carbons, so 2 carbons. This one right here is a CH. And what does that tally up to? Well, we got 1, 2, 3, 4, 5, 6. Oops, I forgot to write this CH2 right here. Here's our 7th carbon, matches up, right? 12 hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Got all of our hydrogens accounted for, and obviously the 2 H's have stuck around. That is our final product.